UV mapping is the 3D modeling process of projecting a 2D image to a 3D model's surface for texture mapping. The letters U and V denote the axes of the 2D texture because X, Y, and Z are already used to denote the axes of the 3D object in model space, while W, in addition to X, Y, Z, is used in calculating quaternion rotations, a common operation in computer graphics. UV texturing permits polygons that make up the 3D object to be painted with color and other surface attributes from an ordinary image. The image is called a UV texture map. The UV mapping process involves assigning pixels in the image to surface mappings on the polygon, usually done by programmatically copying a triangular piece of the image map and pasting it onto a triangle on the object. UV texturing is an alternative to projection mapping, e.g., using any pair of the model's x, y, z coordinates or any transformation of the position. It only maps into a texture space rather than into the geometric space of the object. The rendering computation uses the UV texture coordinates to determine how to paint the three-dimensional surface. In the example to the right, a sphere is given a checkered texture in two ways. On the left, without UV mapping, the sphere is carved out of three-dimensional checkers tiling Euclidean space. With UV mapping, the checkers tile the two-dimensional UV space, and points on the sphere map to this space according to their latitude and longitude. When a model is created as a polygon mesh using a 3D modeler, UV coordinates, also known as texture coordinates, can be generated for each vertex in the mesh. One way is for the 3D modeler to unfold the triangle mesh at the seams, automatically laying out the triangles on a flat page. If the mesh is a UV sphere, for example, the modeler might transform it into an equirectangular projection. Once the model is unwrapped, the artist can paint a texture on each triangle individually, using the unwrapped mesh as a template. When the scene is rendered, each triangle will map to the appropriate texture from the decal sheet. A UV map can either be generated automatically by the software application, made manually by the artist, or some combination of both. Often a UV map will be generated, and then the artist will adjust and optimize it to minimize seams and overlaps. If the model is symmetric, the artist might overlap opposite triangles to allow painting both sides simultaneously. UV coordinates are optionally applied per face. This means a shared spatial vertex position can have different UV coordinates for each of its triangles, so adjacent triangles can be cut apart and positioned on different areas of the texture map. This means a shared spatial vertex position can have different UV coordinates for each of its triangles, so adjacent triangles can be cut apart and positioned on different areas of the texture map. The UV mapping process at its simplest requires three steps: unwrapping the mesh, creating the texture, and applying the texture to a respective face of polygon. UV mapping may use repeating textures or an injective, unique mapping as a prerequisite for baking. The example I use is a banana frosted flake. This variant of Kellogg's popular Frosted Flakes cereal contained real banana pieces. The bits of banana in this cereal was adhered to the flakes, as nut pieces are in certain other cereals. When the cereal was on the market, its sister cereal, Frosted Flakes, was still going by the name Sugar Frosted Flakes. According to an ad when the cereal was introduced, Kellogg's Banana Frost Flakes delivers real bits of banana and great banana taste in every bite. On the back of one box, Tony the Tiger is quoted as saying, "My new Kellogg's Banana Frosted Flakes have real appeal."